This is the setup for the lab, the acid-base lab, determining Ka by half titration of a weak acid. And we are trying to determine the pKa, and that's the Ka of our weak acid. And you can see here that this is a drop counter that is holding a pH meter. It's attached to this ring stand with a right clamp. And then also attached to the ring stand is the burette clamp that is holding on to the burette. Something to note that in your beaker, and I would recommend a 150 milliliter beaker for this titration. Here's the pH meter. You don't want it resting on the bottom, so there's a screw over here on the left that allows you to pull the pH meter up and down and set it to the appropriate level in the bottom of towards the bottom of the beaker. Now, that pH meter was in a little bottle here that had this rubber ring. So you're going to want to take off the ring and the cap so that you'll have enough room to move that pH meter inside of the drop counter. We need to rinse our burette with some of the sodium hydroxide. So I have my beaker of sodium hydroxide. I have a funnel, and I'm going to put a funnel there, and I'm going to make sure my stopcock is closed, and then I'm going to pour a few milliliters in there. Okay, take the funnel out, and now I want to tilt it on its side and kind of rinse it out, kind of run it down the sides, because I want to get anything out from inside that could affect my calculations. If there's any water, it will change the pH, the molarity, the ending pH. Anyways, we're going to rinse it out. We're going to do this 3 times. Here, I poured it out. Okay, we're going to pour a little bit in, and we're going to do that 3 times. And after you've done it 3 times, then you pour a few milliliters in, and you're going to let the base run through the tip. Now you're going to notice that a little air bubble will form in there because you don't have very much in the burette. Eventually, when you fill the whole thing up, there's going to be enough pressure in there that when you turn the stopcock, it's going to push out all the air. The reason that you want all the air out of the tip of your burette is because these are calibrated to deliver an exact amount. So whatever is in the tip, if it's air and you have not gotten rid of that air, it's going to believe that when it pushes the air out, it's going to believe that it actually gave some volume, and so that's going to affect your calculations as well. Science is fun. Okay, to actually start this experiment, I need to plug in both sensors like we did for the colorimetric with these plugs right here, and I've turned it on, and then it gives me some options for my sensors already. And what I'm going to do is I'm just going to hit build in the lower right hand corner, and it's going to say, create your first page. Now we're going to actually run a graph. Whatever I click first is going to be my y-axis, and for my y-axis I want it to be pH. So you see there's a chemistry section. I'm going to scroll down until I get to pH. I'm going to click that first, and then I'm going to scroll up until I get to drop count. I'm going to click on that. Now in the upper left there's a graph in that middle selection. I'm going to click on that. It's going to give me a preview. It says y equals pH and x equals drop count, and that's what I want. So I'm going to hit OK. And so now I have an empty graph of pH on the y-axis and drop counts on the x-axis. Now when dropping the drops through the drop counter, you're going to want to adjust I know it's hard to tell exactly, but this doesn't have good resolution. You're going to adjust the stopcock just barely so that the drops start coming out about 1 to 2 per second. So I gently go until I start getting that There we go. We start getting drops. Okay, now I want you to notice that when it starts dropping, the light starts going. Okay, so you know that when you have distinct light, that separate flashes, then you know you have this distinct drops. If you go too far, you lose it. Okay, so then you're gonna have to clean the lens or stop. So just gentle, gentle, and it can go pretty quick, but you want 1 to 2 per second. There we go. We get distinct drops. If you mess that part up, then you're going to have to start the whole thing over again and get a new sample of acid, because it counts the drops, and that's going to help you find the half titration point. So if you at some point get a steady stream, you're going to have to start over. Try to practice getting the distinct drops a couple times before you put your acid beneath the drop counter. We just now finished our run, and I need to figure out how many drops I actually put into the beaker with the acid. So I'm going to actually select this graph menu, but in a second, so it's going to cover up my graph. So I'm going to pull it over. You can do that. Just put your finger on it and pull it over. I'm going to hit graph here, and it's going to give me some options on the right-hand side. There we go. And there's an arrow in the upper left, and I click on the arrow. And I want to know how many it had right here at the top. So I hit that top part, and I think that was the end. There's some arrows that I can actually scroll through and move according to where the number of drops moves along the x-axis. So I'm going to go all the way to the right, and I see that my total number of drops was 643. And that was at a pH of 12.11. So I'm going to use that 643 when I calibrate my drop counter. Once you have finished your run, you're going to have a graph that looks something like this. And you can see that there's this long buffer region, kind of where you had a lot of drops, but there wasn't a big change in pH, and suddenly it spiked up, and then it leveled off again up high. So we want to calibrate our drop counter now. So we need to press the lower right-hand button, which is Experiment Tools, and then the fourth option down is Calculated Data. And then in this lower left, you're going to type in volume equals. In order to do that, you have to hit the ABC button down there to get the QWERTY keyboard. You type volume equals, then you hit your numbers back. And then there's a button here that says Measurements. You click on Measurements, and you hit Drop Count, which is the second option down. And once you have done that, so I hit drop count, my volume equals, and then I want to say times, which is over here. You can see that there's that number pad times, and the volume that you should have gotten from, that you actually dispensed from your burette. In my case, it was 29.01, 29.01, and divided by the number of drops, and in this case mine was 643. Once you have entered that in, then you just hit return, and then you've got the calculation, and you hit done, and then you go back to your graph. And now to actually get that volume, you need to hit that lower left hand corner graph, and it gives you these options, and click on there's this lower right hand one that looks like a list. And this is the line graph properties. You click on the measurement, and you would, instead of drop count, you select fluid volume and say OK. And then I'm going to get rid of this graph for a second, and we can see that now I have volume along the bottom with pH, and this is going to allow me to find the this is going to help me to find the volume at which we have the equivalence point. In the hood here are our two chemicals working with us in the lab. On the left, with the yellow label, is our 0.20 molarity sodium hydroxide. And you're going to use this large Erlenmeyer flask to pour out 75 or so milliliters. Doesn't have to be exact, because you're going to end up putting it into the burette to get the exact volume. On the right is the unknown weak acid that you're going to be finding the Ka for. So we have that Erlenmeyer flask, and we have a graduated cylinder, and this one is just a 50 milliliter graduated cylinder, and this would count for in your materials. When it talked about the 100, you can just use this 50 is fine. You brought your own beaker that you're going to be adding the acid to, and here is the pump pipette. Oops, sorry, there's the pump pipette, and it's attached to the pipette. It's a 10 milliliter pipette still in the sleeve, and I'd like for that pipette to stay in that sleeve when you finish with it every time, so it doesn't get contaminated by what's become a rather dirty surface inside this hood. Anyways, you're going to, for 5 times, use the 10 milliliter pump pipette to get 10 milliliters out of here, put it into the graduated cylinder. The reason that I would like to do this is because once you have done that 5 times, you'll know exactly, so you won't lose count of how many times you've taken out 10 milliliters. You just can find when it finally gets to 50, and then take that 50 and pour it into your beaker for the acid, and then take that beaker back to the desk. But this all stays here, and that pipette goes back in the sleeve.